Okay, hello beautiful people. This is 5.3, factoring and solving polynomials. So previously in previous lessons, we learned about the difference of two squares, for example, and that special pattern was a squared minus b squared is equal to a plus b times a minus b. For today's lesson, instead of having the difference of two squares, we're going to look at the sum and difference of two cubes. So when it was squares, it had to be subtraction. But for cubes, not so much. It could be plus or minus. It's also a little bit more user-friendly than some of the other patterns that you've had. So a cubed plus b cubed is equal to a plus b. So this part stays the same except you don't have the cubes. Times a squared minus ab plus b squared. Difference of two cubes is a cubed minus b cubed, so you have a minus b, and then times a squared plus ab plus b squared. What's the difference between the plus and the minus? Well, the sign should always alternate for the middle term for your trinomial. So it should go plus, minus. And then for this one, if this is minus, this one has to be plus. That's the only thing that changes. So let's take a look at this first example. Factor 125 plus x cubed. Well, we need two cubes in order to do this. So I already know by heart that 5 cubed is equal to 125, and then this is just x cubed. So this is acting like your a, and this is your b. Go ahead and press pause right now for just a moment and try following this formula and plugging everything in, where this is your a and this is your b. Press pause and do that if you would, please. Okay, so if you follow the pattern, you will have 5 plus x, because that's your a plus b, times 5 squared, which is 25, plus 5x plus x squared. Notice mine has changed from here to here. This one is in standard form, so you should have x plus 5, and then parentheses x squared plus 5x plus 25. That is your final answer, completely simplified. Okay, so the next one, it says to solve by factoring using special products. So if I'm going to solve by factoring, I know that I need to have one side equal to 0. Right now, that's not happening for me. So the first thing that I'm going to do here is to subtract 27x from both sides. And then I have 64x to the fourth minus 27x is equal to 0. Not quite a special pattern yet. I know that 4 to the third power is 64, but x to the third power is not x to the fourth. But I'm looking at these two terms, and I see that they both have an x in common, so I'm going to go ahead and factor that out. And then I'm left with 64x to the third minus 27 equals 0. Now, I could write each of these as cubes. This is going to be 4x to the third minus 3 to the third equals 0. Not done yet. So we'll expand this out, and I have x times 4x minus 3. Now, I'm using this pattern right here. So this is a minus b. The next thing I should see is a squared. So 4x squared, that's 16. X squared. Now if this was plus, I'm sorry, if this was minus and this is plus, it says AB. So 3 times 4x is 12x. And then lastly, plus b squared. So plus 3 squared, which is 9. All of that is equal to 0. So my next step is to solve now. So this is what we use our zero product property. So this would be x, because this is a factor, equals 0. 4x minus 3 equals 0. And 16x squared plus 12x plus 9 is equal to 0. Well, these are easy because this is just x equals 0, so that's one of my answers. For this one, I would add 3 and get 4x equals 3. Divide both sides by 4 and I get x equals 3 over 4. This one, not so much. It's not a special product, so I can't just factor it. I'll tell you now, it's not factorable. So when I get to this point, I'm going to use everyone's favorite, your favorite and mine, quadratic formula. So a is 16, b is 12, and c is equal to 9. So plugging in, remembering that the quadratic formula is x equals negative b, so negative 12, plus or minus the square root of b squared, so that's going to be 12 squared, minus 4ac, so 4a 16 times c, which is 9, all over 2a. The a for us is 16. Okay, let's do a little bit of simplification. Negative 12 plus or minus the square root of 12 squared is 144 minus 4 times 16 times 9 is 1728. 144 minus that, and then I'm going to do 2 times 16, that gives me the 32. This is negative 12 plus or minus the square root. When I subtract these two, I get negative 1,584 over 32. Okay, so now we're not freaking out because this is quite a huge problem. I'm going to tell you what I just did from here to here. This was negative 1,584. I found that this has a perfect square. It's 144, that's my perfect square, times 11. What else did I do from here to here? Well, notice because this is a square root of a negative number, I also pulled out the I. I'll put that in the end in just a little bit. For now, negative 12 plus or minus the square root, well, 144 is 12, the square root of that. So I'm going to take that out. What's left over in the square root is 11, and then I still have that I at the end. All of that is divided by 32. Now you can just do a little bit more simplification. I know this is a mad long problem, but you're hanging in there pretty well. Looking at all three of these numbers, something goes into all three of them. What is it? 12, 12, and 32. What goes into all three of those? I'm thinking 4 also. Thanks for answering me. So if I divide this by 4, divide this by 4, and divide this by 4, I have negative 3 plus or minus 3 radical 11 I over 8. And there you have it. It's a nice one, huh? Good long problem for you. All right, let's go on. Now, here's an old school one. Factor by grouping. Some of us remember that, some of us not so much. Grouping. Think about this. The most famous or infamous grouping symbols that we use ever are parentheses. So what we do to factor by grouping is we group them. You group the first two together and the last two together. Once they're grouped, we factor. So just looking at these two terms, what do x cubed and minus 2x squared have in common? Well, they both have an x squared, so I'm going to factor that out. Then, looking at this part, if I took out x squared, what's left? X minus 2. Great, your first one is done. Now, for the second part of that, looking at negative 9 and positive 18, well, because it starts with a negative, I'm going to factor out a negative. And then what goes into 9x and 18? Not 2. Just kidding. See, you are paying attention. I knew it. 9. And then what's left? You're going to write that in parentheses next. X minus 2 is left there. So now you're looking at this as a term, and you're looking at this as a term. What do these both have in common? Well, looking at them, they both have an x minus 2 in common. So what I'm actually doing here is I'm factoring that out. So when I factor out that x minus 2, what's left? Well, if I factor this one out, then what's left still is x squared. If I factored it out of here, what's left is minus 9. Almost done, but not quite just yet. Now there's nothing left for me to do with this x minus 2. You're done. But this x squared minus 9 is a special pattern. Don't get dizzy when I move this. A squared minus b squared equals a plus b times a minus b. It's a difference of two squares. So the a and the b, they're both perfect squares. So what squared gives you x squared? X. And then what squared gives you 9? 3. So it's going to be x plus 3 into x minus 3. And now we have factored by grouping. That's as far as you can go. Typically, you won't always have a perfect square here to continue on, but a little more work for us to do, but we can handle it. Okay, let's look at number 3, and they also asked me to factor by grouping. Looks like a lot of numbers there. I'm looking at all of them, and I see that they all have something in common. I'm looking at 2x to the 4th, 6x cubed, minus 18x squared, and minus 54x. What do they all four have in common? Well, 2 goes into all of these, so I'm going to just right off the bat factor out a 2. They also have an x term, so I'm going to take that as well. Now what's left over? Well, 2 goes in here, so that would be an x cubed left over, plus 3x squared, because 2 times 3 is 6. X times x squared is x cubed. That's me checking myself as I go along. 2 goes into here, negative 9 with an x left over. And then 2 goes into 54 27 times. Go ahead and check my math. Now this one is different from the previous one. Remember, the number 2 said factor by grouping. This one says solve by factoring. So that's why you have that equals 0. You want to solve. You want to have x equals something at the end of this. Okay, so now I'm going to go ahead and group. So join me. Or actually, you can go ahead and press pause and do your grouping. So here and here. And then factor the way that you just saw me do over here. Press pause for reals, and then try it, and then unpause when you're done. Okay, this was a long one. So I factored these by grouping, and these both had an x squared. These had a negative 9, so I was left with x plus 3. That's your common term that you are now going to factor out. Left over, once I took out that x plus 3, which is this one, I still have an x squared right here. Once I factored the x plus 3 from here, I still had a minus 9. Then, same thing that you had here, x squared minus 9. That's x plus 3 times x minus 3. Remember, notice here, I left all of these the same throughout. This 2x, 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 2x. X plus 3, x plus 3. And then you're solving the rest. Okay, solve. 2x equals 0. X plus 3 equals 0. X plus 3 equals 0. Remember, this is a repeated root. You don't really have to write it twice, but I just did. X minus 3 equals 0. So if I divide both sides by 2, I have x equals 0 for the first one, negative 3 for the next one, negative 3 for this one, and 3. Those are all of your answers. Bueno, good job. All right, next and final set here, solve by factoring. So that means we need to factor. Some of you use a factor box, some of you just do it in your head. I'm going to use a factor box because that's what we mostly use here in our department. So if I want to solve this, remember, if you're using a box, that your first term goes into your first box, last term goes into your last box. Now, I need two numbers that will multiply to give me negative 21x to the fourth, and that will add to give me 4x squared. I'm thinking 7x and 3x, and I'm thinking that this one, the negative, has to go with the smaller number. 7x minus plus a negative 3x is 4x squared. That's correct. These are both squareds. And then when I multiply them, I get that. So that makes me feel good about my box. 7x squared and negative 3x squared. Good. Now factor using your factor box. These both have an x squared in common. These both have a 7. These both have an x squared. These both have a negative 3. So I could write that as x squared plus 7, x squared minus 3 equals 0. Then I'm going to solve each set. X squared plus 7 equals 0, x squared minus 3 equals 0. Minus 7, x squared equals negative 7. Square root both sides, x equals positive and negative, radical 7i. And then for this one, plus 3, x squared equals 3, square root. This will be positive and negative, radical 3. Those are your 4 answers there. Okay, I think you might be okay to fly on your own here for the next one. Go ahead, see what they both have in common. This is going to be 2y, so you have y to the fourth minus 9, period. There was going to be more there, but there's not. Equals 0. So you could use a box, but why would you? Because this is a perfect square trinomial. This is y squared plus 3 and y squared minus 3 equals 0. Do me a favor and press pause right now. And then while you press pause, what I'd like for you to do is to solve each of these sets of parentheses. Okay, thanks for pausing and working out your problems. So for this one, if you divided both sides by 2, you got y equals 0. For this answer, you subtracted 3 on both sides and then took the square root, and you got y equals positive or negative radical 3i. Don't forget the I on that because that was a negative 3. And then for this one, you have y equals positive and negative radical 3. It's okay to consolidate and put y equals 0, positive and negative radical 3, positive and negative radical 3i. All right, that's it for this lesson. Thank you for watching.